Okay, students, so welcome back to algebra. And now for those of us who have already printed out the group practice question, I apologize, I'm changing things up. The group practice question, which quite honestly was basically just like the independent practice question. It's just exactly like the group practice question, the way you do it. I'm not going to go there. I want us to learn something. So with this second one, we're going to do things a little differently. So now, our rule before, when we were doing the other problem, I gave you the example of this. I said, if we look at this type of scenario, 2, 6 plus 3, 6 equals what? We said we kept the bottom number and we add the top numbers. Well, that works fine. 2 plus 3 is 5. That works fine if these numbers are the same, but if they're not the same, we're going to have to change them. Here's an example of how we're going to have to change them. So I want to make both of these the same thing. Well, one's a Y, which is a letter, and the other is an 8. This is like making me like frustrated just looking at it. Well, how can I turn a Y into an 8? I mean, you can tell me how to turn an 8 into a 4, or, but how do you turn a Y into an 8? Here's what we're going to do. We're going to take both of these numbers, and we're going to multiply this number by y over y, which is just 1. And if you multiply anything by 1, you get 1. Doesn't change anything. So I'm multiplying top and bottom by y. Here on this side, hopefully you guessed it, I'm going to multiply it by 8 over 8, or 1, the same number. So look what happens when you do this. 8 times 2, 16. Over 8 times y, 8y. Minus 3y times y. 3y times y, if you remember from your multiplication of exponent rules, you keep the 3, you take the y, 1 plus 1 for the exponents gives me y squared. And on the bottom, 8 times y, again, is 8y. So now look at this problem we got here. Now this makes sense. Now, I have an 8y and an 8y on the bottom. So that means my answer is going to have an 8y on the bottom. And that's fine. Now the tricky part of this one here is when I go to add and subtract them, I have to recognize the 16 and the 3y squared are not like terms. Sorry. So I'm just going to go 16 minus 3y squared because I really can't subtract them together. And that's the answer. 16 minus 3y squared over 8y. Can't do anything else about this. You just leave it be. Okay. So let's turn over to the other one. So this one is another problem one. Oh my God, this doesn't look good. Let me get another piece of paper real quick. So if you're looking at the actual independent practice problem, it was similar to this, but I'm going to change it up. Now last time what we did is we multiplied one side by y, one side by this. So let's do this. 2 over z plus 3, which looks just like the other one, minus 7 over, they did z plus 3, I'm doing z minus 3, because I want to make this a little bit more challenging. And it's both z plus 3, 2 minus 7 is negative 5, we're done. But this has two different ones. So here's the problem. I'm going to get really frustrated, because how do you make this into that, or vice versa? The 8y seems like so much easier than this. This is what you have to do. Watch this. So I'm going to multiply both of these by 1. So what I'm going to do is I'm going to multiply this side by z minus 3 over z minus 3, which is just 1. On this side, I'm going to multiply the top and bottom by z plus 3, the opposite of this. Now watch very carefully what happens here. Z minus 3, z plus 3, I'm just going to leave it on the bottom. And on this one, z minus 3 times z plus 3. Now it's messy, but the one thing I can see here is I have the same numbers on the bottom. Now here's where it becomes a little sloppier. I got to multiply the top numbers. So here I have to do 2 times z minus 3. And here I have to do 7 times z plus 3. Okay, how you guys feeling? Hopefully at this point you're pretty, okay, I kind of see what Flans is doing here. It's long, it's drawn out, but in all honesty, I'm trying to keep it simple as possible. So I see these numbers on top, and before I do any addition, I'm going to have to do this. Distributive property. Okay, so let's do that. 2 times z is 2z. 2 times negative 3 is negative 6. All over z minus 3, z plus 3. Plot minus, keep the denominators the same. 7 times z is 7z, not z7, 7z. 7 times 3 is 21. Combine like terms. So in the end, so I'm just adding these up. I keep these. So at the end here, on the bottom with my answer, I'm going to have z minus 3, z plus 3. It's annoying to write them a bunch of times, but we got to keep track of everything. So here's my work. So 2z minus 7z minus 5z. Minus 6 minus 21 minus 27. Now I can't reduce this number on top. I can't add 5z and negative 27. They don't go together. They're not like terms. I look around here. I go, there's nothing else I can do. So what do? I stop. That's my final answer. All right, guys. Sometimes you might be able to factor these, and that's a little bit different. But for now, you don't have to factor. Okay, so I'll talk to you guys later. See you tomorrow.